Hello everyone, thanks for coming to see my talk. My name is Ron Fernandez, and here I'm going to tell you about some results of my PhD research related with the vocal divergence and playback response in Olive Sparrow. So we know the importance of the acoustic signals in bird communication systems, since they are used for resource defense, mate attraction, and species recognition. So for the individuals are very important to understand the message encoded within the signal to take suitable decisions. In some birds, the signal recognition involves neural mechanism and sensorial experience that led to vocal learning and discrimination abilities, where isolation scenarios could play an important role in the geographic variation and the divergence of their perceptual systems. So we were interested in studying the geographic variation in acoustic signals and the perceptual abilities in a Neotropical songbird. This species is the Olive Sparrow, Arremonops rufivirgatus. Currently, there are several positions about the taxonomy of this species that includes different recognized subspecies and taxonomic groups, but the most complete consider a complex of 3 main lineages. So we focus our study at 2 levels. The first one related to 3 taxonomic groups, rufivirgatus, superciliosus, and verticalis, and the second one in the context of allopatric, where we can find 5 discrete populations. There are Gulf, Pacific, Chiapas, Central America, and Peninsula. Looking for a pattern of geographic variation, we asked us if does the sound vary throughout geography matching with either taxonomic groups or allopatric population? And how strong is the sound divergence compared with the recognized species within the genus? So we collected sounds from several libraries and completed the lake of information with field work, where we identified territories, marked individuals, and recorded their songs. In the map, I'm showing the location where we obtained recordings. We include vocalizations from our study species and their congeneric species. Then we performed a principal component analysis to reduce the spectrotemporal dimensions of our analysis. PC1 and PC2 were related to spectral variables, and PC3s were temporal variables. We found significant difference in the spectral variables for both groups and allopatric population. For instance, we can see that Peninsula verticalis individuals exhibit the lower pitched song. Additionally, our acoustic divergence analysis also revealed that the difference among groups and population were equivalent to the difference found among recognized species. So here we have some examples of their songs. There are the song of Gulf, this is the song of Pacific, and this is the song of Peninsula population. On receiving perception to the divergence, we asked if birds could discriminate among local and allopatric sounds, where we expected a stronger response to local than allopatric sounds. So we performed the playback experiments in 2 allopatric populations in Mexico, the Pacific population at the biological station in Chamela, Jalisco, and the Peninsula population in Mérida, Yucatan. Our playback design includes acoustic treatments, local songs, Pacific or Peninsula in base of location, 4 allopatric songs, and data-specific songs, where we used songs from a population from Colombia, the black-striped sparrow, Arremonops conirostris. And we measure a set of behavioral variables related with vocal activity and physical movements of the birds. And look at this. Here we found something interesting. In the Pacific population, the birds only discriminate their specific songs and respond in a similar way to all the allopatric songs. Here the response were vocal mainly. On the other hand, for the peninsular population, we found that birds responded stronger to their local songs only and did not recognize the allopatric songs. Here, the responses were physical mainly. Return to our question and hypothesis, we asked if songs vary throughout geography, and this was more evident in the taxonomic groups. Additionally, we found that peninsula individuals are one of the most divergent in voice, divergence equivalent to recognized species within the genus. This variation may be driven by the isolation in tandem with selective and or non-selective factors. Besides, we asked if birds could discriminate among local and allopatric songs, and they did. But we got an interesting pattern of asymmetric behavioral response, where the Pacific population cannot discriminate among songs, but the peninsula can. Asymmetric response has been a topic of recent interest, some explanation considering learning by social experience, sexual selection, and ecological difference among population. Finally, we consider that isolation times among population with cultural drift and ecological selection could be acting on some sensory system of Olive Sparrows, promoting the asymmetric behavioral response to playbacks. So if self-isolation during pandemic promotes several behavioral changes in us, imagine what geographic isolation could do in thousands or millions of years. With these results, we are watching how two populations from the same species take different behavioral ways, where some divergence may act as a barrier in a future secondary context scenarios. I want to thank to my co-authors, the institution that bring financial support, and our research and its staff, and all the people that assist me in the field. This is it. I hope you enjoyed this presentation. Thanks for your attention.